Hello, welcome to today's demola, and today's lesson we're going to be covering ionic and covalent bonding. This is going to be really important as we start to transition out of module 2 into module 3 about periodicity. So, let's get straight into it. Okay, so we're going to kick it off with ionic bonding. And when we're talking about ionic compound, every single time it's going to exist as a giant ionic lattice. I do like to break down the word just to give me a better understanding of what does giant ionic lattice mean. So, giant, repeating, ionic bonds, lattice, regular structure. That's literally what you need to know about that definition. So it is a repeating regular structure containing ionic bonds. That's what it means. And if we have to define an ionic bond, very important definition: electrostatic attraction between oppositely charged ions. If you want to be fancy, metal cations and non-metal anions, yeah. But literally, electrostatic attraction between oppositely charged ions gets you the mark. Cool. So what do we need to know really? There's a transfer of electrons between metal and non-metal atoms, and the overall charge of the compound is 0. The only reason why I don't really like this sentence here that I put the dot next to is because if you have a compound ion, so like a nitrate ion, can you really say, I mean, they're still non-metals, but I just don't really like the definition, yeah? Cool. So I've just drawn some examples. This one you should remember from GCSE, but we're just going to add a bit of a twist. So you've got sodium chloride there, and on the other side we've got magnesium bromide. So you can see here, let's quickly correct that. Magnesium, oh my goodness, sorry. Magnesium bromide. Cool. So you can see that there. What we do differently in A level, and guys, it saves you so much time, just draw the outer shell. So for example, sodium ion there, literally no electrons in the outer shell. Same with magnesium, saves you so much time. And then you can see here with the dot and cross, you have the crosses for the chlorine electrons, and then that dot for the one it gained from sodium. And then for here with the bromine, we're not going to make a mistake again. Sorry about these notes. You can see that we've got the 7 electrons in its crosses, and then that one that it gained from magnesium. But then we have to have 2 bromide ions, yeah? Hope that makes sense. Sorry about the mistakes I made. Let's push it forward. The very important thing I wanted to talk about here with ionic compounds is, because you should have done bonding, you should have done dot and cross when it came to GCSE. But physical properties is very important. So whenever we talk about an ionic lattice, a giant ionic lattice, we're going to say it has a high melting and boiling point, because your ionic bonds are very strong. Right? That electrostatic attraction between the oppositely charged ions is very strong, so it requires a lot of energy to overcome. And what we'd also say is that they only conduct when molten or dissolved in solution, because those are when the ions are free to move. So if we throw it back, GCSE chemistry, GCSE physics, when we talk about solid, liquid, and gas, these are the kind of diagrams that we used. And if we described it, we would say a solid that they vibrate in position. Liquids are free to move around each other, whereas the gas would be they just move randomly in all directions. Yeah, so that's why if it's a liquid, so molten or dissolved in solution, it's able to move around each other. So those ions are able to move, hence they can carry a charge. In a solid state, if they're only vibrating, charge ain't gonna move through that. Yeah, so in terms of ionic lattices, this is kind of what we want to focus on. Just remember physical properties, and then if you need to revise your dot and cross, revise your dot and cross. Okay, so covalent compounds, we've got a lot more to talk about. Let's talk with a covalent bond. An electrostatic attraction between a shared pair of electrons. Definition, bish bash bosh. Cool. And just know that it's occurring within the nuclei of the non-metal atoms. Yeah? Happy days. We have our single covalent bonds, so there's one shared pair of electrons. Let's look at methane, for example. Methane, you can see in each bond, again, rushing through this because it was technically GCSE, but you can see the carbon, say it's the dots, puts in an electron to each bond, and the hydrogen puts in another electron into each bond. Cool. Hope that makes sense. And you can see here, that is single covalent bonds. Nice and simple. Yeah? We have a multiple covalent bond. You have more than one shared pair of electrons in each bond. So look at this oxygen molecule. Oxygen has 6 in its outer shell. So you can see it's got 2 pairs of electrons that aren't involved in bonding. And from now on, we're going to call electrons that aren't involved in bonding lone pairs of electrons. It's got 2 lone pairs there on each side, and you can see that they've put electrons into the bonding pair. So for the bonding pair of electrons, there's 2 bonding pairs of electrons, yeah. But you can see they all put it in to that one there. Hope that makes sense. Cool. So you see nitrogen, similar thing. Nitrogen has 5 electrons in the outer shell. So it's got 2 electrons each that are part of a lone pair. And then in the middle, it's got 3 electrons each in terms of the bonding pair. Hope that makes sense as well. So it's put 3 electrons into bonding, it's put the other 2 to the side, so that they can both have that full 8 electrons in its outer shell for stability. Hope that makes sense. What we're really going to focus on is a dative covalent bond. So dative bond means that one atom, one of the elements, has donated both electrons to the shared pair. And a very common example of this is ammonium ions. So we said nitrogen has 5 in its outer shell. So let's do some highlighting here so you can see. You can see these are as you would expect. Nitrogen puts in an electron, hydrogen puts in an electron, so you have a shared pair. What's happened, this is the dative bond now. This is the dative bond. So with this dative bond, you can see here that the nitrogen has actually donated both electrons. So this is a H plus ion that's come at the top. The nitrogen is going to donate both of the electrons so that we can form a covalent bond there that helps you to form the structure of your ammonium ion. And if we just quickly focus on here, let's move this down a bit for space reasons. If you were drawing it in this format, you would do an arrow to the hydrogen to show that nitrogen is giving those electrons to the hydrogen. Yeah, but it forms a covalent bond. Just be aware of that. Also, look this up, the oxonium ion, you can see here, that has dative bonding as well. Won't spoil it for you. Do your research, yeah? Cool. And another term we just need to be aware of is the average bond enthalpy. So this is the average amount of energy required to break a covalent bond. And if we have a greater bond enthalpy, there's more energy required to break the bond. It must be a stronger bond. So that's just something that you just need to be aware of as well. You will be able to see in questions like, they normally will have a table, and on that table you have different bond enthalpies. So like it might be like CH bond or NH bond, stuff like that. We are going to get into more of that in a later video. I hope that dative bonding makes sense. It's the only new one for our A level. Yeah, where one atom is donating both electrons to the shared pair. Hope that makes sense. Okay, so this is a bit tacky as well, but we need to talk about bond angles and shapes of molecules. So whenever we're doing this, we need to focus on how many bonding pairs of electrons there are and how many lone pairs of electrons there are. And that will help you to determine what shape it is, what bond angle it is. So let's just go through the examples now. When we have just one bonding pair, I'm going to call it one B pair, yeah, one bonding pair, that is linear. What's also linear is 2 bonding pairs, 0 lone pairs. So 0 lone pairs as well. Those are both called linear. Bond angle here, as you can see, is 180 degrees. 180 degrees, 180 degrees. Next we need to talk about is trigonal planar. So trigonal planar, we're going to have 3 bonding pairs, no lone pairs. And between each angle is 120 degrees. Yeah? Cool. I also think it might be nice to put in an example. So trigonal planar, for example, BF3, something like that. Yeah. Linear can be something like carbon dioxide is linear. Yeah. Let's look at this, bent or angular. So the very common one for this is water. And the bond, water. And the bond angle between this one is actually 104.5 degrees. I know it's going to be really annoying trying to learn these values, but trust me, you do need to know them. So 104.5 degrees. Now, what's happening here is in green, this is called a lone pair. So this one has 2 bonding pairs, 2 lone pairs, and that's why it creates that angle. Because you'll learn about this electron pair repulsion theory. Your bonding pairs repel equally, but then the lone pairs repel the bonding pairs more strongly, which is going to reduce your bond angle. Yeah? Just be aware of that. Tetrahedral, very common example, methane. Yeah? So the bond angle here is 109.5 degrees. Yeah? Tetrahedral. And it's just going to be 4 bonding pairs. No lone pairs. Next, we go to the trigonal pyramidal. Very common example of this one is ammonia, yeah, where we have that lone pair in green. We've got 3 bonding pairs and 1 lone pair of electrons, yeah. Trigonal bipyramidal, I can't think of an example off the top of my head. I will probably add it in to the edit if it doesn't come up into my head. But trigonal bipyramidal, what you'll see here is actually the funny one. It's got a 90 degrees here. So this is 90 degrees. I forgot to say, trigonal pyramidal. This is 107 degrees. 107 degrees. Again, we'll just highlight them for your ease. So 107, 109.5, 120, and then 180 here. Cool. So trigonopyramidal, it's got some that are 90 degrees, and it's got another one. If you try to imagine it in 3D, it's got another one that's 120 degrees. So that one's a bit more tacky. And with trigonal bipyramidal, you just have 5 bonding pairs. Yeah, it's 5 bonding pairs of electrons. So I hope that makes sense. The best example I could think of is phosphorus pentachloride. That's the best example I could think of. Now, octahedral is another one. Octahedral is literally just 6 bonding pairs. Yeah. So octahedral, if I try to show it here, 6 bonding pairs, and your bond angle is 90 degrees. I really wish there was an easier way of me trying to explain this to you, but literally, you kind of just need to know it like that. So there will be tables that you can search up online that will help you out a lot more. But that's kind of what we're dealing with when we talk about bond angles. I thought it was just good to cover, be aware of it, but I would really struggle to explain it to you any better than this. So for this one, you got sulfur, hexafluoride. That's a good example. But unfortunately, this is something that you just need to know. Yeah, it's literally something that you just need to know. Doesn't come up that frequently, but unfortunately, you do need to know it. Now, another thing, drawing methane. So methane, like we said, was tetrahedral because if you look at the central atom, the carbon, it's got 4 bonding pairs. Yeah. Whenever you're drawing this, I always want to go like this. While you do 2 in the plane, you're going to do 1 in front of the plane, 1 in front of the plane, and you're going to do another behind the plane. I wouldn't really stress yourself over these diagrams all that much, but just be aware when my thing works. That's kind of what they're looking for if you have a question about drawing the 3D structure. Yeah. Becomes more important when we're talking about optical isomers in topic 6. And I just wanted to kind of show you a play-by-play. You find central atoms, so for example, carbon, then you need to know the total number of electron pairs. Here it was just 4. Then you need to know lone pair versus bonding pair. Fortunately, again, 4 bonding pairs, no lone pairs. And then you need to use that knowledge to figure out the bond angle and shape, which would be memorization. Very unfortunate that's just memorization, but it's how it goes. The only part that I really wanted to say for exam technique is this guy. Yeah? Always mention this in the question. It will get you a mark or 2 off the bat. Bonding pairs repel equally. Lone pairs repel more strongly than bonding pairs. Just say that, it will get you a mark. Yeah? Other than that, unfortunately, it's going to be a memory exercise. Very unfortunately, it's going to be a memory exercise of all of this. But you've got time to learn it. So don't stress too much. Okay, everyone, Excel. We're done with that. Let's look at some questions. So, first question we've got here, this molecule. Draw a dot and cross diagram of the molecule. Think back to your knowledge from GCSE. Think back to what we covered about covalent bonding here. Then I need you to name the shape. Again, think about what's the central atom. I'm going to give you a hint. It's this guy. Think about the central atom. Think about how many bonding pairs we have. Just know, even if it's a double bond, triple bond, it counts as 1 bonding pair. Then we've got this question. State what is meant by ionic bond. Know your definition. Know the dot and cross diagram. And then just a quick throwback. Calculate the number of barium ions that is in 1.5 grams of barium oxide. So you've got all those questions to dig your teeth into. Have a go, and we'll discuss it. Okay, so we've got quite a bit to go through. I'm going to try and do this the best I can. So if we look at this first question, yeah, what you should be able to see is, if you start with the central atom, carbon has 4 electrons in the outer shell. We saw by the diagram that there's a single bond, and we saw a double bond there. Just draw that, and then let's use our knowledge from the periodic table to know how much is left. Yeah. Ideally, you're filling out 8 electrons in each shell, which is why chlorine, you got the other 7, you got the other 6, and then oxygen, you got the other 4. That should be from GCSE. Yeah. I don't want to be really harsh, but that should be from GCSE. And I'm just trying to see if there's anything. Yeah. Okay. Nothing there. Then what you should then do is think, okay, for the next question, it has to be memory. I'm so sorry, but it literally is memory. But if you don't remember the name, just fill out the information you have. You can always find out that there's 3 bonding regions. You can look at this diagram and say, there's a bonding region here, there's a bonding region there, there's a bonding region here. Just think about how many bonds there are. That's a good start. Then think about the molecule, carbon. How many electrons does carbon have in its outer shell? Well, it's in the fourth group, right? So it's got 4 electrons in the outer shell. Now that we think about that, there's 1 electron here from carbon. There's going to be 2 there. There's going to be 1 there. So it's exhausted its 4. Those are the things you need to think of to say, I've got 3 bonding pairs and no lone pairs. Literally, you've said that, you've already gained a mark. Yeah. If you remember that the shape is called trigonal planar, then that's an addition. Cool. Then, like I said, think about electron pairs bond. Yeah. So I would literally say, I've always said that they repel equally. Saying that they repel gets you a mark. Far apart as possible, weird way to say it, but still fine. And then electron pairs or bonding pairs repel. Literally just anything like that will get you a mark. So just make sure to say it in your question. Yeah. Now, when we get to the next question, we were talking about ionic bonding. Guys, literally, like I said, definitions you just need to learn. Electrostatic attraction, they love it. Positive and negative ions. That was only 1 mark. Sometimes it will be 2. But just know electrostatic attraction between positive and negative ions. Then your dot and cross diagram, something that you should be able to do from GCSE. Again, don't like to be harsh, but it is the reality. So barium, you'll see it's in group 2. I would look at that and say, it's a metal. Thankfully, I'm just going to put a circle around it. They didn't even put a circle here. Yeah? Fine. And just remember 2 plus there. Oxygen, I see, is in group 6. So it wants to gain 2 electrons. So I'll take the 2 electrons from barium, and then the rest of its electrons are going to be from itself. And that's how we're going to draw that dot and cross diagram. If you need to do that, do a recap of GCSE if you need to remember that. Cool. Now, this question literally was just a throwback. I wanted you to just remember about Avogadro's constant, which I believe is in your formula book. So remember, find out the moles, mass divided by molar mass. That's the calculation they've done here. When you find out the number of moles, we know that in 1 mole is 6.02 times 10 to the 23. So if you did this calculation, you should have got this as your answer, and that would have get you your 2 marks. Okay, thank you so much for paying attention. We are wrapping it up now. So in terms of what we do, dot and cross diagrams, I've said it's from GCSE because it is, but it's very important that you do know how to draw them because they do ask it virtually every year. If you don't know how to do dot and cross, please cover it because it will almost definitely come up. Guys, periodic table is there for your use. If you need it, use it. Don't make assumptions, yeah? You don't want to drop a silly mark because you were like, oh, I'm too cool to use a periodic table. Please just use it. It's there for your help. Shapes and bond angles. I've literally said it, guys. Like I showed in the question, there are ways that you can still score marks without knowing the name of the shape. If you know the name of the shape, it's a nice mark to add on. Can be the difference between your BNA or an ANA star, yeah? So make sure that you know the shapes and the bond angles. Remember the definitions for ionic and covalent bonding. Again, I just like definitions, guys. If you can remember a definition, then you're scoring an easy 1-2 marks, yeah? So just make sure that you know those definitions, especially the easier definitions, because there are some harder definitions down the road. Now, what do we not do? A lot of these are going to be about neglecting stuff. So electron pair repulsion, like when we're saying that bonding pairs repel each other equally, stuff like that. Just throw it in. Whenever you have a question about shapes, throw it in because it's probably going to be in the mark scheme. Yeah. Something that a lot of people do, again, this is going to be more of a module 3 problem, but confusing metallic compounds with ionic compounds, just because in a way they're kind of similar, but make sure that you don't confuse the two. They are different. And in data covalent bonding, I'm not going to cap to you. It rarely does come up, but if it does come up, you want to be the person that gains 3-4 marks on the question. Yeah. So just keep it in mind. Don't completely neglect our boy. But that is it for this lesson. So I do appreciate. I think that was probably a bit longer. I don't know the length of the videos, but it was probably a bit longer. Thank you for your attention. Thank you for listening. I hope it was helpful. If it was, like, subscribe, please. Any questions at all, this is the more important part. Any questions, drop them in the comments. I'm going to do my best to answer them. We've got the Instagram and the TikTok, both at A-Star Demola. We're posting Beat the Examiner videos up there, which help you with your exam technique. I've been a Demola, A-Star Demola, whatever. Thank you for listening. I'll catch you in the next one. Bye for now.